So let's look at a place where reciprocal functions come in handy in an actual situation that you might actually be interested in terms of real world stuff. This is kind of a pared down example. There's not a lot going on in here, and it may seem silly, but it's the start of where things go when we actually use reciprocal functions in the real world. Suppose that a group of friends are planning to throw a party once they can all get together again. Since they plan to invite lots of people, they arrange to rent a big space and hire a DJ for $600. They also want to make sure there's plenty of food, which will cost $12 per person coming to the party. If they could split up the cost among everyone coming, how much would each person pay? I often find that when I'm doing problems like this, that it helps to come up with some examples. So let's write some examples. If there's only 5 people coming, I hope there's a lot more than that. But if 5 people come, the total cost is going to be the $600 they have to pay plus $12 times 5 people. So that's going to be 600 plus 60 equals $660 is the total. That's the total cost, though. They're going to divide it up amongst each person. Each person pays $660 divided by 5, which is going to be, let's see, I think if I divide that up properly, 5 goes into 660, $132. That's a lot of money for each person to pay. Let's do another example and see what happens. If 20 people come, the total cost is going to be 600 because I got to pay for the space and the DJ plus 20 people times $12 per person. So it's going to be 600 plus 240. Oh boy, that's going to be a lot more, isn't it? That's going to be $840. That's the total cost, though. So each person pays the 840 divided by 20. So in this case, if I do 840 divided by 20, I'm going to get $42. That's a lot more reasonable than 132. So the more people that come, you divide up the cost among more people, so it becomes a little bit cheaper. Let's do this in general. If X people come, then the total cost is going to be 600 plus 12x. Each of those X people pays $12, but that's the total cost. The cost per person, each person pays that $600 plus $12 per person, and we divide that up among all X people who come. And remember, we can distribute division, so we can write this as 600 divided by X plus 12X divided by X. So it's 600 divided by X, plus 12, because 12X divided by X is just 12. And look at that. That looks a lot like our reciprocal function. So what we're really graphing here is Y equals 600 divided by X plus 12. So when I go to graph this, I'm not going to put a scale on here because it's going to be a little bit funky. I know that X can't be 0. We can't have 0 people coming. So I definitely want an asymptote at X equals 0. 12 is the minimum cost. If lots and lots of people come, this 600 gets divided up among more and more people, and we could end up paying pennies if it's just a little bit. Plus 12 means that everybody's got to pay the $12. So Y equals 12. And this is our stretch factor. If only one person comes, they have to pay all 600 plus 12. So up here, this point is one person is going to pay $612. But as more people come, the graph looks like that. On the other side, it'll be a mirror image down here. We don't care about this negative one so much because we can't have negative people come, but that's what the graph looks like. And we can use that graph to figure out how much each person pays depending on how many people there are. I'll leave the analysis of this one to you. I'll put it up in the notes when I post those later on. Thanks for trying.